Alright, welcome back to another Alephium video. This will be episode 2 of our series. In the first episode we covered kind of what the, the folders that we get with the basic Alephium install, as well as what the folders all mean from a combined perspective, as well as looking at some of the contracts, going over data types and strings. In this video we're going to be going basically beyond that, and we're actually going to be running that contract, and we're actually going to be getting values from that and building unit test cases, which are one of the many ways that you can actually test to make sure that you're getting the right output for things without having to push it to the blockchain. So yeah, let's get started. So test cases in most, if not all places, are going to be found in the test folder. I believe that you can write test cases in other folders, but by default it is going to be in the test folder. If it is not specified like that or you've altered it, then it will be in that folder, right? But by default, it'll be in this test folder here, and you'll find a Ralph types.test. That's what I named mine. Yours will probably be like test token.test or something like that. And what I did is I took the base import that it gave us for that token faucet types, and the withdraw. And I end up importing our Ralph types and our Ralph types, which basically this Ralph types is the contract name. Ralph types is the artifacts that it builds off the contract itself with the TypeScript. And so we're met here by a kind of a describe thing of our unit test itself. This is kind of describing what it is that we're initializing before the test has actually even taken place. And then once we have all of this defined here in our describe, if I can highlight that, we then will write the actual test case here that's going to be using these params here and this initialization to run the actual test here. So let's go over this line by line, just because I think that makes this easy. We're describing test contract ID as a string, test token ID as a string, test contract ID address as a string. We're describing the test params fixture as basically the params that we're going to pass to the actual argument that we're wanting to test in this case. And so in this case, we're taking our test contract params of Ralph types.fields, and we're going to send x of big int. We initialize the fixture variables for all the tests. So we get our current node provider here, which is this is the node that you're running on the DevNet. We're waiting that project.build test contract equals a random contract ID. So we're just coming up with arbitrary contract value. Test token IDs, test contract ID, and so that just builds up kind of the basic foundation for a contract. And then we actually have the test params fixture, which is going to be using an address, which is going to be using that test contract address up here, which has been already redefined here as address from contract ID test contract address, which we can look at test contract ID, and that gets it from a random contract ID. So all this is just like randomly generated, right? And there's comments here to basically say exactly what I just said here. We describe the initial assets that the contract is going to be able to own. This is actually a really cool feature because you can actually specify, hey, I want the contract to have either alph, another token, ... another token, ... and you can actually interact with those tokens and actually then kind of query up, what tokens are within, what address at what time. And this just makes figuring out what's actually happening at the fundamental layer of the Ralph contract that you've written, right? We have our initial fields. In this case, if we go back up to our contracts and we click data types and we hit types, we can see that we're met with time, condition, text, owner, array, mute, result. And here in the Ralph types, we also have time, condition, text, owner, array, result. So all the same stuff that we had in the first video has now been over here into the initial field section for our initialization. We use n at the end because they are U256 values, and we use string to hex here for text because it is a bytevec, which means that it is a string converted to hex, and that is for blockchain efficiency. We have our array, once again, using that 1n, 2n, 3n, 4n. We have our test arguments. We have our input assets. And this is assets owned by the caller of the function here. So just like we had one for what the contract owns, we have one for what the caller owns and the contract owns. We have test arguments here. This is just going to be that x of 1. So same thing here as it was there. And that's it. That's all the initialization that we actually have. Our it is going to be testing some math for us. It's going to take that test params fixture up here, and it's going to basically use this test params as what we use for Ralph types.test.getTime test params. So we look in our types folder. We have a function called getTime. It's going to call that time using that x value, which we can also see is here. X value here, which I use the same name. I actually think you're required to, I think by TypeScript. But anyways, I use the same name for that, and I pass it into that function of getTime test params. And since the value is 1, if we go and look at this function here, x is going to equal 1. We have our temp struct here that we built. Temp foo.y equals get index 1 times x. So it'll get the index value of 1. This is 0, 1. So it'll take 7 times 1. Should get 7 there. Then it's going to take our time. So in this case, it's going to be 20n times that temp foo.y, which is going to be actually, this is saying get index here of 1 of our array. Okay, so it's going to get index, so it's going to get 2 here. 2 times 1, 2. Then we're going to get time times that temp foo.y. So that'll end up getting, then I'm getting 2 times that 20. And the current result is result. So hopefully I did that math right. I was doing it kind of fast. We'll end up doing the test real quick. So we'll run our compile just to make sure that everything's running properly, and it seems that it is. Then we'll run our npm run test. And we have a failed here. We're expecting 20n, but we got 40. So I was right. So 40n. However, if we set this number here equal to 40 here, and all the statement is saying is expect contract state.field.result to then be equal to 40, and if we check our types here, it would actually change the result to that value of 40, like I said we were going to have. And so we'll save that, and then we'll run this again, and we'll be presented with still a default test that failed. Received expected deep equality. Oh, because the debug message wasn't the one that we were expecting. You can also expect certain debug messages too. So that was my bad, but yes, you can expect certain debug messages as well. As you can see, we test all those test cases. We did in fact have that result being changed to the value of 40 from the original value of 0. We also had a debug message that gave us exactly the output that we wanted and took that value from results. And so let's build our own test case real quick. So we're going to copy this real quick. Command C, Command V, and we're just going to say YouTube example. We're going to keep all the same stuff, except we're going to build a, why not? We'll build a new function here in the get index, right? We'll say that we want so in this case, we're going to take results and we're going to make it equal to array of index. So we'll npm compile that just to make sure that the contract likes that. And we can't do that because we're not using the update fields parameter. So we'll add that because we are going to be updating those contract fields. And bam, everything compiles as expected. And now we can start writing that YouTube example. So we will have our test params here as X. We will do the same thing over here just to keep it the same. And simplify things. Then we'll go back here to our ref types. And we're going to go down here to YouTube example. Instead of saying get time, we're going to say get index. And then we're going to pass those test params. As you can see here, it says that value is not assignable to the parameter index big int, is missing type, but required in type index big int. So this is actually because we haven't reran the contract. Now it should be fine with what we're doing. Yep, it is fine with what we're doing because the value has to be the same value as what we're giving it as the test params. We're going to instead make sure that this does continue to equal certain values. So we'll make sure that our array, we'll get that value real quick. Although I don't think that that'll check that. Definitely want to check the second value, or we'll check the first value. Okay, so that should check the first value of our array then, which is 1, and make sure that it's still equal to 1. We'll then expect this function here, which they'll be basically getting the index of x in this case. And we'll check to make sure that that is equal to 2 because it's getting the, well, we want that index actually to be equal to what x is equal to. So in this case, if it should actually be equal to x of n, actually we can do big int of x. Can't we do that? Can't find name x. That's because we use it up here. But if we passed 1, then we should be expecting 2. So yeah, by default, if you wanted a dynamic case, that would be how you do it. You'd have to, define your variables here and give it the same variable as x. But in this case, it's just going to be equal to 2. And then we don't have a debug message. So since we don't have a debug message, we'll just completely void that out. And we can see that we have 1 passed, 1 failed. We can see here that we expected 1, received 1n. And so if we change that from 1 to 1n, then we have 2 total passed test cases. And so we just built our first test case here. Simple, but you can see how this would be really powerful in the right hands, especially as you build them out and go further into them with looking at contract addresses or looking at what is contained within an address or making sure that certain assets reach the right places. And so these can be really powerful. And I hope you enjoyed the video, and I'll see you guys in the next one. Peace.